Time-traveling photons? Let's ramble about it. Welcome to Season 7 of Shep Rambles, where I am Shep and I tend to ramble about what? Anything and everything. Quantum physics. It is full of wacky surprises. Imagine tiny bits of light called photons acting like both particles and waves, or being mysteriously connected over long distances. Now, scientists from the University of Toronto have discovered something even stranger. Photons can actually spend a negative amount of time zipping through a cloud of super chilled atoms. It's like they leave a material before they even get there. Let's take a look. In a fun update on X, physicist Ephraim Steinberg said, "It took a positive amount of time, but our experiment observing that photons can make atoms seem to spend a negative amount of time in the excited state is up." This neat study was shared online on September 5th, and it's waiting for other scientists to review it. Now, this idea started back in 2017 when Steinberg and his student Hosea Sinclair wanted to explore how light interacts with atoms. When photons hit an atom, the atom gets excited, like it's jumping up for joy. When the atom calms down, it releases energy, making the photons visible again. Sinclair's team wanted to measure that time delay, which is sometimes technically called a group delay, and learn whether it depends on the fate of that photon. Was it scattered and absorbed inside the atomic cloud, or was it transmitted with no interaction whatsoever? At the time, we weren't sure what the answer was, and we felt like such a basic question about something so fundamental should be easy to answer, Sinclair says. So they built an experiment to see how long this excitement lasted and found something surprising. Sometimes photons would zoom through the atoms without interacting, but the atoms still got excited. I'm getting excited just reading this. And when photons were absorbed, they seemed to pop out again, almost instantly, like magic. Now, to understand this interesting behavior, the team worked with Howard Wiseman, a physicist from Australia. They realized that photons don't always travel in a straight line with a set time. Instead, they can act in all sorts of strange ways. Sometimes, photons can seem to travel so fast that they finish their journey before the atom has even calmed down. This leads to a negative time value, which is, kind of bizarre. I can promise you that we were completely surprised by this prediction, Sinclair says, referring to the matchup between the group delay and the time that the transmitted photons spent as atomic excitations. Now, after confirming their findings, the team planned another experiment to test this wild idea of negative time. In their follow-up, they looked at two ways that a photon could go. Sometimes the photon just simply zooms past the atom without stopping, and then there are other times it gives the atom a little nudge before bouncing back. When scientists measure these photons, they can't always tell what happened. This means that they can sometimes see a negative time value for how long an atom stays excited, making this discovery a super fun puzzle in the world of quantum physics, something that is way above my pay grade. So, what do you think about time-traveling photons? Do you think this discovery could inspire new techniques for using photons in quantum computers? Perhaps it could help us expand our understanding of time and causality in physics. Hey, we might even be able to create new types of materials with unique properties that respond differently to light. Let me know in the comments below what you think. If you're new here, consider liking the video because you know what? We really like it when you do. YouTube likes it also because they see that and they say, hey, you know what? Some other people might want to watch this too. Not only that, but use those protons and photons of yours and subscribe to the channel. Click that notification bell so that you get notified of more rambling content in addition to other fun programs that we have here on the channel. Thanks so much for watching. We'll see you next time. Have a killer awesome day.